Hello, Dave Kenworthy here. It's the 27th of the 8th, 2021, and I'm playing around with the Cubit analysis that produced this quite stunning column of pi calculations of 10 times pi when the digit producing the cubit in inches is multiplied by 10 over 9 to transfer the digit to Shusi, and that's per Jim Allison. And what we haven't looked at, what I completely overlooked in all the excitement, is how the scaling is working with these units, and it was something that I wanted to explain and it just completely went out of my mind. But when we have unit 1 for the Shusi of 0.66, which is in Berryman's book, we get a digit using 10 over 9 of 0.7333, and that's what was being used in this spreadsheet. Every one of these digit lengths here, making a cubit, are being multiplied by 0.733, every one. There's no other digit being used in this spreadsheet, and all these versions of pi are being produced using one digit. So there's a commonality there in every one of these digits. Now what's happening with the scale of these digits? And 1 is the Shusi of 0.66, 0.994318181 recurring, that's 175 divided by 176, is this, which is Jim's Shusi that he's using, producing a digit that Berryman's first digit, really, that's the Egyptian digit. That's the Giza digit, I could say, I don't know. And this one is the Greek or Roman digit, and we can see the scale. The unit is this that we're using to apply the scale. That's the unit that divides into these three, and it divides as follows: 4400 in that digit, 4375 in that one, and 4374 in that one. So Berryman's found this distance between the two digits, this scale. But the top of the scale is 4400, and we know there are 440 cubits in the side of the GP. So if we multiply by 4, we're getting the scaling factor that's going on at the GP. So we know that's 10 times the Giza base length. So we're getting 176, 175 and 17496. And it's all whole number as we've come to learn from the analysis of Giza. And every one of these cubits that I'm calculating is producing an earth circumference and a Giza base length, but I'm just looking at earth circumferences here because we want to see what's going on with this Shusi. Now, I wrote a book a while back called From Stonehenge, Cracking the Megalithic Code, the what's he called, the Ramanujan pi, that was it. And I called it Ramanujan pi because in the calculation that Ramanujan uses, there's 99 times 99, which is 9801. And 9801 is the difference between the two versions of root 2 that has been found by Berryman. If you multiply 140 over 99 by 9801 over 9800, you get 99 over 70. So that's why I call the book Ramanujan pi, because he uses 99 times 99 in his calculation, and I was suggesting the ancients knew that. They knew that number, they knew that square, and it's built into the calculation of pi. You can't really argue with that because Ramanujan's calculation is on Wikipedia. You can see it, and you can see that number. So we're going through now. I've decided to put some more versions of pi in this spreadsheet. And the first one I've put in is Egyptian pi, which is 256/81. And interestingly, there are that number of Shusi in it, and this number of digits. And it's producing this cubit and an Earth circumference of 31.111 recurring, which is 44,800 feet for the Great Circle, and that's bigger than the 25,000 mile circumference one, which is not a problem. But what I'm saying is this is the cutoff at Giza. And the other thing that's quite strange is I'm getting this version of pi. And I can show you what it is, because all we have to do is multiply this by 99. And it's 3.125, or 3125 divided by 990. That's the version of pi that's being used. So we can see how 99 is such an important number in some of these versions. There's one, and there's one, straight away. And 99's in this one, but it's a numerator, not a denominator. And obviously these two multiply out, because these are the qubits that Berryman's giving us, and we can see why they're working together, because that is 2. Divide that into that and you get 2. So you're getting 14 there. And that's the way it's working. But for me, the interesting thing is the Shusi. Where does it fit in all this? Because Jim's produced this amazing analysis, and it's obviously super serious. Well, I've done the Egyptian pi there, and I've done Stonehenge pi here. Now, Stonehenge pi, I've said, is 3.1416. And I've done a little calculation here. That's Tom's Aubrey circle in feet. If you multiply it by 3.5, you get 31416 exactly. So it's in there as well. And it is, because it's in my book. I've written about it. And it's this design at Stonehenge is super complex. It's a pi manipulation device, the Stonehenge Aubrey circle. It's all in my book. I've been writing about this kind of stuff for a long time, with no response, because, I mean, it's bound to be going over everybody's heads, isn't it? Because we've never seen it before. But here it is now, standing out like a sore thumb. Now we've got this Shusi, and that's the explanation that we've been looking for. And here it is. Every one of these versions of the Cubit here is against a digit of 0.733. Digit always 0.733. Look. It's in the calculation, it's automatically built in. And what this means is, when we divide the Cubit by the version of pi that is in this column, we get a fixed number. 10's Shusi. It's incredible. I'm going to get rid of that, it's not in the right place. So, here is the Shusi. The diameter that the Cubit is calculated against. So 19.8, the version of pi. What is it? 3. So pi has fallen down to 3 here in this. Well, we've gone away from, this is probably the cutoff, I would say. We've gone past pi here. But you get a good version of pi if you multiply some of these by 99. Oh no, not that one. I'm going the wrong way there, that's higher up. But anyway, oh, maybe if you divide by 99. Yeah, there you go. You divide by 99 when you get this low down. So everything comes back into focus against pi once you get past base 100 and back down to base 99. It's very complex. But we've got this Shusi as a diameter. And what we've also got in this model is the Earth circumference diameter. We just do the same thing. We divide in the Cubit there by this version of pi, and we're dividing the Earth's circumference there by this version of pi, and we're getting a fixed diameter of 7920 miles. And we all know that there are 792 inches in a chain. And we all know that this is an imperial number. And we all know that this system is working using imperial measure. That's 25,000 miles. That's 22,000 miles. That's 24640 miles. This is all coming out of these columns here. And all these ideas have been pulled from Berryman. You see, I've got the 3 versions of his Cubit there. I'm applying the same thing against John Neal's Cubit, and that's giving me these numbers here. So we're getting all these versions of pi. This is Alexander Thom's pi here, 1632/520. It's not really producing anything meaningful because it's working in a different base. And if we look at what happens when we use Tom pi, we've got to use a different diameter for the Earth's circumference. They weren't using that one when they were using Tom's version. They had to amend it. But I can't talk about that now. That's for another day. But this is very clearly showing us that we can get all these different qubits using a constant Earth diameter, a constant diameter for the qubit, and variable pi, which is being worked by the digit being transferred to the Shusi, where we get 10 pi. And to me, this is a big breakthrough at Giza for anyone that's interested in historical metrology. And I think somebody needs to recognise this. I mean, someone who's got more authority than I have needs to go through this and have a good look at it and confirm that everything's stacking up. So that's it for now.